Hello everyone, welcome back. Let's devote a few videos to the security. In this particular video, we will learn about encryption, decryption, public and private keys, and man-in-the-middle attack. Now, let's say that Bob is trying to send the message to John over the internet. Let's say that they are trying to chat using Facebook. So, let's say Bob messaged John, "Hello John, what's up?" And this message is transmitted through the internet. So if some information stealer guy can intercept this message, he will be able to steal it. So if some guy, let's say Al Capone, wants to see what Bob and John are talking about, he can intercept this message and steal information. So, what can Bob and John do about that? Well, Bob can try to code his message. So, his message, he can apply some secret and then message is coded. Now, coded message, let's say, looks something like this. And then John receives this. This is totally trash. You cannot see what is the message from this coded message, but John can also apply the same key that Bob applied, and then he can transform this random string to the message again. And then if you transmit this instead of the message, so if you transmit this instead of the message, if someone intercepts the message in the middle, he cannot do anything with this. He doesn't have a way to decode this message because he doesn't have a secret. Secret is present at Bob's place and at John's place. Attacker doesn't have a secret. Okay, what we just described is called man-in-the-middle attack. This stealing information, so someone intercepts the message. He is only reading the message, he is not altering message, but he is stealing the content. Since he is doing that from the middle of the communication, that's why this security attack, is called man-in-the-middle attack. And these operations that Bob and John are doing, so Bob is coding his message, so this is the message, and then he codes the message, then it becomes this coded message, and then John on the other end is decoding. So that's basically what's called encoding and decoding. So when you're transforming your message, your readable message, original message, and you apply some secret key to transform that original message to something unreadable, that process is called encoding. And on the other hand, when receiver wants to, from unreadable message, to transform that to a readable message, that's called decoding. Let's first see one problem. So in the next example, we have John and Mike, and both John and Mike, they want to send some data to some Java server, and they want to do that in a secure way. But we said that if they want to encrypt their data that's going through the internet, and then if Java server wants to decrypt that data, both John and Java server needs to have secret, right? But how can John send the secret to the server? That's the problem number one. Unless John goes physically, let's say that this Java server is, I don't know, some AWS service. So John would need to go physically to Amazon headquarters to bring his USB and to say, this is the secret that I want to use to communicate with AWS. That's problem number one. How can John share his secret with the server? Problem number two is that if Mike stole John's secret, Mike can basically read communication between John and Java server. So all that Mike's need to steal data from John to steal his communication with Java server is just to steal his secret, right? And the third problem is that if you have million clients, so John is client number one, Mike is client number two, I don't know, Alice is client number three, and you have a million clients, which is not unusual in when you have a lot of clients like Facebook or Google or whoever, then every single client needs to has its own secret, and that's a lot of secrets. So how to solve this problem? Well, what we described at the beginning of the video, Bob encrypting his data and John decrypting his data on his end using the same secret, that's symmetrical encryption. So they are both using same key, that's why it's symmetrical. But we can create asymmetrical encryption. What that means? That means that when Bob encrypts the data, he will use secret 1, and on the decrypting side, another secret will be used, secret 2. But those two secrets, they need to be paired. Let's repeat once again. Bob used secret 1 to encrypt the data, and John used secret 2 to decrypt the data. So let's say that we have another pair, secret 3, and here we have secret 4. So Bob can use secret 3 to encode the data or encrypt the data, and John will use secret 4 to decrypt or decode the data. What's the point why I created another pair? The point is that you cannot encrypt with secret from this pair and then decrypt with this secret from another pair. Now, instead of calling these things secret 1, secret 2, blah blah blah, I will rename this thing. I will say this is called public key 1. So when you encrypt data, you are using public key, and when you decrypt data, you are using private key. I will delete second pair. Okay, so when we encrypt the data, public key; when we decrypt the data, private key. Okay, let's get back to our problem where John and Mike are trying to securely send the data to the Java server. Well, now Java server can create public-private key pair. So private key, and it's important to realize that Java server will create public-private key pair, but private key will only be on the Java server. Java server won't share private key with anyone. So when you are generating public-private pair, you don't share private keys. You are sharing only public keys. And public key is available. Anyone can have it. So John has one public key, Mike has another public key. The same public key. So this is the private key and this is the pair of this key. This is also the pair. I mean, those two are the same. So when John wants to send data to the Java server, he needs to do what? To encrypt the data using public key, and Java server can decrypt that data using private key. Mike can also use his public key, which is the same as John, to encrypt the data, and Java server will use private key to decrypt the data. You remember that we had 3 problems previously. First of all, John cannot steal anything from Mike. They both has the same public key. Problem number 2 was when we were using same secret on the both sides, then every single John, Mike had different secret. Now all clients, they all have the same public key. And the third problem was that John needed to deliver to the Java server somehow his secret. But here, private key is not delivered to John and Mike. that private key is generated and kept on Java server, so it's not delivered through the internet. We don't have a problem with delivering secret key or something like that. Public key, Java server just published this public key, let's say on some place on the internet. There's a name for that place, but it's not that important. So both John and Mike, they can download this public key from the internet. So we solved all three problems that we had previously. Now you may wonder, okay, but why we use symmetrical encryption if this asymmetrical encryption is way better by all parameters? Well, it's not way better. Asymmetrical encryption is way slower. So it's more secure, but is way slower than symmetrical encryption. We said the problems that symmetrical encryption has, but the main advantage of symmetrical encryption is that it's way faster. And that would be basically it about encryption, decryption, public and private keys, and man-in-the-middle attack that we described before. See you in the next video.